Okay, number 7. So we've got this formula here, 2n plus 3, okay, or this expression, right? And it's taking any positive integer, right, for n. So what we mean by integer, of course, we mean whole values, okay, and it's a positive integer. So the first positive number, of course, is 1, right? Then we've got 2, 3, okay, so that's what we mean by integers. Integers are just whole numbers, okay, because they refer into positive, we have to start with 1, all right? And then we've got this 2n plus 3. Well, let's break this down. Let's work out what 2n is first, okay? So 2n just means to double n, doesn't it? Or times it by 2. 2 times n. So if I times this by 2, I get 2. If I times that by 2, I get 4. Times that by 2, I get 6. Times that by 2, I get 8. Times this by 2, I get 10, and so on, right? 12 and 14. Okay, so 2n actually produces even numbers, doesn't it? Okay? They're all even. Right? And then we're told to add 3 to it. So if I add 3 to my result, 2 plus 3 is 5, add 3 to that is 7, add 3 to this is 9, add 3 to this is 11, add 3 to this is 13, where am I going? 13, add 3 to this is 15, add 3 to this is 17. Okay, so we end up with, just looking at that, that's 13, isn't it? Yeah. We end up with odd numbers, don't we? If you think about it. So 2n plus 3 is odd, right? It's always odd. Okay? Now, just sort of justify it a little bit more, to give a bit more reason, just think about it. The 2n bit here, the 2n bit, you end up having 2, 4, 6, 8, and so on. 2n is always even, isn't it? Okay? So 2n is always even. And then when you add 3 to it, it makes the result odd. But if you think about it, 3 is an odd number, isn't it? 3 is an odd number. So what effect we're doing is, 2n is an even number always, and then we're adding to it this 3, which is an odd number. And when we add an even and odd number, it always comes out to be odd, right? If you think about it, even and odd number, it always adds up to be odd. Here then, we'll do exactly the same. n then, let's go through them, okay? 3n, so times it by 3 this time, so that's 3, 6, 9, 12, 15, 18, 21, and then we're going to add 2 onto it, right? So if we add 2 onto it, we get 5, 8, add 2 onto it, 11, 14, 17, 20, 23, okay? Now notice this time, odd, even, odd, even, odd, even, odd, right? So sometimes odd, sometimes even. Okay, that's what 3n plus 2 is. Okay, sometimes odd, sometimes even, basically. And the reason for it, well, if you take 3n, look at the 3n there, 3, 6, 9, 12, 15, 18, 21. Well, that's sometimes odd, sometimes even. Okay, the 3 times table, isn't it? Okay, so 3n is the 3 times table, or multiple of 3. Okay, multiple of 3's, and that, you know, is sometimes odd, sometimes even. Okay, sometimes odd, sometimes even. And then we're adding 2 onto it. Now 2 is an even number. Okay, so if we're having odd or even with 3n, right? That's what 3n is, odd and even. And when we're adding 2, which is an even number, well, when we add odd and even, it will be odd, and when we add even, it will be even. So that's why you end up having sometimes odd, sometimes even. So I hope that clears that up for you.